All right, I've got a Raspberry Pi set up here. Just to get started, I have it connected to an LED. Eventually it's going to be connected to the IoT relay. And that is this thing here. But I wanted to get a Python script started and test it out before I work on the IoT relay. So I've got, it's a very simple circuit. I have the black cable, the black jumper connected to ground, and the white jumper connected to a GPIO pin on the Raspberry Pi. I believe it is GPIO 18. And this is connected to the LED here on the breadboard with the 330 ohm resistor on the path to ground. So this is the setup that I'm going to be working with. In the next video, I'm going to be generating a Python script using some AI tools to be able to toggle this GPIO. All right, in this video, I'm going to be asking Cline, which is a Visual Studio extension, to generate a Python script that will allow me to toggle a GPIO on the Raspberry Pi on and off. So, can you write a Python script that toggles a given GPIO pin on the on a Raspberry Pi? Okay, and we can see it's thinking. There we go. And here it goes, writing the script for us. All right, now we'll just do a quick review of this. Got some arguments, setting up the GPIO mode, gathering the initial state, toggle function, main function. Okay, yeah, that looks good. So I'm going to save this. Okay, now I'm going to copy the file to the Raspberry Pi. And SSH into the Raspberry Pi. So now I'm just going to run this script and make sure that it runs successfully. Should have some help there. So the LED is hooked up to GPIO 18. So we'll say delay 2 seconds, count, we'll do it 4 times, and then pin is 18. And it looks like that's running correctly. So now I'll do a video with the script running in the background so that you can see the LED actually lighting up. All right, so I'm going to show the LED toggling on and off. You can see that the script is here. I'm going to press enter, and then you'll be able to see the LED blinking. So here we go. All right. So that is a good test, we should be ready to hook this thing up to the IoT relay at this point. All right, now I'm going to go into the IoT relay. So this is a relay from Digital Loggers, and it has a few different plugins here. So there are two that are normally off, and that will turn on when a positive voltage is detected on the input here. We have one that is normally on and will turn off when there's a high input detected, and then we have another that is always on. And to control this, we just need to insert some jumpers and then screw them down with a flathead screwdriver. So go ahead and do that. So the one on the left, actually I need to loosen it up a bit first. There we go. So the hole on the left is going to be the active signal. Get that down reasonably tight. Okay. And the one on the right is going to be ground. Okay. Now we can plug this back in. So the next step is to hook this up to the Raspberry Pi and a power supply itself. So I've got another example device or test device. It's this light strip over here. So this is an LED light strip that's connected currently to the normally off socket there. So it's normally off when the signal is received over the GPIO pin. It should switch on until the GPIO is turned off. And the setup was the same as with the LED. So the black jumper is connected to ground, the white jumper is connected to GPIO 18, and I'm going to be running the Python script from the previous part. Pull it up here. Delay is going to be 3. Count is going to be 6. And pin is 18. Okay, let's try that. There we go. And that's it. So yeah, you can see that we can program this power source arbitrarily, and we can also make it dependent on inputs or sensor values. All right, I've got the SHT30 temperature and humidity sensor. I bought this from Adafruit, and it comes with these jumpers already attached. So the black is ground, red is power, white. So this is an I2C device. So the white is SDA, and the yellow is SCL. I actually didn't have any 4-pin connectors, so I went ahead and soldered on the male part of the sensor to a male-female jumper, just because I'm impatient and I didn't want to wait for a 4-pin connector to get here. So that's why this extra piece is here. Yeah, anyways, it's pretty straightforward. You just connect each pin to the appropriate location on the Raspberry Pi, and I can provide a diagram in the video, but ground is the third one on the right. Then we got power. So this device supports a pretty large voltage range. I think it's 2.15 volts up to 5.5. So I opted to go to 3.3, which is on the top left pin, the Pi here. And then the SDA is the next pin down from the 3.3. So it's that second pin from the top on the left there. And then SCL is the one below that. Get this wired in. There we go. So we've got 4 pins there. And so this sensor is going to be used in the incubator, and it's going to be the input control to the IoT relay. The IoT relay, instead of being connected to a light, it's going to be connected to a seedling heat mat. And so the heat mat allows you to, it's basically just a heating element that you can set at a certain temperature. So this temperature sensor will be there to measure the temperature when it gets too cold. The software that I'm going to write is going to turn on the heat mat, and vice versa. When it gets too warm, it'll turn the heat mat off. So in the next segment, I'm going to create a small Python program that reads the temperature and humidity from the sensor on the Raspberry Pi. All right, so now I'm going to ask Cline to create another Python script, and it's going to read the temperature and humidity from the SHT30 sensor. So let's see. And you create a Python script that reads the temperature and humidity from SHT30 I2C device connected to a Raspberry Pi. Convert the temperature into Fahrenheit before displaying it. All right, so it's creating this new file using SMBus2 library, the address 44. I must have gotten that from the datasheet. I think that's right too, which is pretty amazing. Some commands. We have a hard-coded bus there. It's probably fine. Send measurement command. Okay. Okay. While true, read. Okay, so let's have it. I wanna add some arguments. So let's add some arguments that allows the user to specify whether or not to read continuously at a given interval, or to read just once. Also provide argument for the bus and device number. Okay, let's look at that. So we got argparse now. Makes sense. Still reading from, yeah, we have the bus number and device address. I have some arguments here. Continuous, default read once and exit, okay. Interval is the number of seconds between readings. Okay. And looks pretty good. So I'm gonna save that. And I'm going to SCP that over. Okay, now I'm going to run it. So we're gonna run it. I'm gonna run it continuously, and I'm gonna do an experiment. So as it's running, I'm going to blow air onto it to see how it affects the temperature and the humidity, and expect the humidity to raise quite a bit and the temperature to rise a little bit. So continuous interval, we'll say 1 second, bus 1, address 0x44. And I'll make the screen bigger a little bit so you can see. All right. So now it's about 76 degrees and it's around 31% humidity. So I'm going to start blowing on the sensor. You can see both the temperature and humidity rose quite a bit. That's pretty cool. So the next step is going to be incorporating the sensor, integrating it into a program that takes the temperature as input and then switches on the heating pad as appropriate, depending on the temperature. All right, in this video, I'm going to be generating a script that regulates the temperature in the incubator using the temperature sensor. So it's going to be combining a couple of the previous scripts that we made, the GPIO toggle and the SHT30 sensor. I'm just going to ask Claude to combine that into one. Okay. Create a script that periodically reads the SHT30 temperature and uses RaspberryPi GPIO library to toggle GPIO 18 on the Raspberry Pi. Whenever the temperature is greater than 80 degrees Fahrenheit, turn the GPIO off. Whenever the temperature is less than 75, turn the GPIO on. Okay, it's thinking. It wants to read the SHT30 sensor file. It wants to read GPIO toggle. Thinking. Here we go. Okay, let's look at it. So it's importing this read temperature. It's importing the GPIO library. It's got the default temperatures. It's got some arguments. GPIO pin. Interval looks like 5 seconds. That's probably good. Default temperature for high and low. The bus number, which is 1 for the SHT30. Address for the SHT30 is 44 hex. Okay, so that looks pretty good. We're setting up the GPIOs. And then it's looking at the temperature, comparing against the threshold, and toggling that, only changing it if the state needs to change. So that looks good. This is the main function, checking for sanity there on the temperatures, and then that looks good. Current state, and then it goes into a loop, reads the temperature. It also reads humidity, which I'm not really using right now. And then it passes in the temperature to the GPIO control. When that's done, it sleeps for the specified interval, which is 5 seconds. So that seems right. I'm going to accept that. All right. So now I'm going to copy this to the Raspberry Pi. Okay, and it's over here on the right. And it looks like it's going. it's successfully reading the temperature there, and since it's going to take a while for the temperature to change, so that's why there's no additional output. But yeah, you can see as initially it was off, and then the temperature read as 65, which is less than the default threshold. So the GPIO was turned on, and it will be on until it gets to greater than 80 degrees, which will be turned off. So yeah, this is a basic Python script for having this feedback loop between the temperature sensor and the seedling mat, which has the heating element in it, and that's going to be under the spawn bags or whatever you're trying to heat up or incubate. So in the next video, I'll go over the full assembly of everything and provide a demo of the script. In this final video, we'll be walking through the complete incubator setup. So I've got the Raspberry Pi here and the temperature and humidity sensor. I'm going to go ahead and put the sensor in the tub. And yeah, I'm just going to lay it there. It's going to pick up the ambient temperature once I turn it on. Also got two heat mats. We've got one on the left, one on the right. And these are what's going to be modulating the temperature within the range that we prescribe. We've also got a spawn bag on top of a shelf. So the goal is to keep the air around the bag within a particular range during colonization. The heat mats are plugged into this normally off slot here on the switch, and our program is going to be toggling this white pin here, the GPIO, to turn this on and off. So I'm going to go ahead and put the lid on and come over here to the script. So I have the temperature range specified as 75 on the low and 76 on the high. It's just for demonstration purposes. In a normal grow, you'd probably do 75 to 79. Depending on the species, it might vary a little bit. So yeah, once the temperature exceeds 76, the heat mats will be turned off. And once the temperature is below 75, they'll be turned on. And so I'll go ahead and run this. So it looks like the temperature is a little high, which means that it's not turned off yet. Sorry, it's not turned on yet. So once it drops, it's gonna have to drop below 75. So I'll go ahead and fast forward here to when it detects 75 and switches back on. It's almost below 75 degrees now. There we go. So it dipped below 75. GPIO turned on. You could probably hear the click in the background. And so yeah, it'll stay on until it goes back up to past 76 degrees now. And so yeah, that is it. Now we have a complete incubator setup with automated temperature controls. Thanks for watching.